Well, hi, good morning, and thank you so much for joining me here. It's it's February 24th. It's about -2 outside, which is warm compared to how it's been. And supposedly some rain is coming later today. Boy, that's not a good idea. Not when you've got 4 feet of snow in your yard or on your roof. Okay, did I mention my backyard shed roof collapsed during this? I don't know if I mentioned that or not, but I can't get back there because there's chest-high snow all the way back there. Okay, so I ended the last video with doing a GM and an EM test of this tube and not being too happy about the results, especially the EM test. I realize now, and thank you for sending me an email on this, I made a mistake. It's just coming out of lack of experience with actually using this tube tester. So when I did the EM test, I set the bias incorrectly, and when I read the number on the guide, it said, I think 14 or something like that. I tried to set this to 14 volts when it should have been just 14 on the dial here. That's all it should have been. So with that error made the test invalid. So my plan is to redo the GM test and the EM test for this tube, which I believe to be in okay shape. And then afterwards I want to try to assess the operation of the machine by checking voltages wherever I can. And I don't even know where I can do that kind of stuff just yet, but I want to investigate this O control and the plate pin jack, and just find out what just get a feel for whether this thing's really working right or not. That is the plan. So I will set this up for the GM test, and we will do it again on here. The last time I did it, the GM reading, I don't know, did I write it down? Was about half on this machine what it's been on other machines. So something's not right there too, I think. Okay, let me go. I'm going to start out with a bit of coffee here. Okay, I've got this set for a GM test. Just going to double check because I do not want to make a mistake. B, G, 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 and this doesn't matter. 26431, 26431, and 05200, 05200. Test, off. 10, 6.3. Okay, let's power it up. That's what I say. Should probably give it a fair bit of time here. Let's do the line. We can do the line adjust now. Behaving very nicely. The actual line voltage being applied is 113 volts. The bias for this test is 2.9 volts. So I'll make sure this is set to 2.9 volts. We're on the 10 scale. 2.9 would be right there. Okay. So the short test, not that we should need to, but why not? Okay, totally normal. We can flip this. Whoa. Let's check the current flow on the 3 amp scale. We're reading 3 amp filament amp, 3 amp, just below an amp. Actually, it's wandering around a little bit. Very good. We're ready now to take the test. One quick peek at the line and the bias. Once again, everything's good. Test. There it is. There is the test, and this time it comes out to, we're on the 20 scale, just under 3,000, so it'd be 2,000. You could call that 2,900. Let me write it down here. I got too many numbers written on this page now. So we're going to a new page. 2,900 doesn't sound right at all. If you doubled this, you'd have a much better value. I think the other testers, you know, they're in the 5600 range. 57, 51, 48, these are different tubes. 52, 52, 4800. And the tube 2 we're doing was 5200 and 6000 in two different testers. 5200 and 6000, and I'm getting 2900 on this one. Does not sound at all right. And I think I know what the reason is. I think I accidentally turned a adjustment underneath here when I shouldn't have, and it's one of the earliest adjustments. I almost have to go back to square one, start the whole thing over again if that adjustment is out. So I think I turned it off a little bit and turned it right back to where it was, but I don't know for sure. I could have turned it a little this way or that way, and maybe that's disturbing this. But this is quite a range error. Or you're supposed to multiply by 2. Does it say that in here? Some of these, let me read. 6L6. There's no notes or anything. Okay, oh, well, there is one thing. 3825 is the reject point. So this tube tester is telling me to reject this tube, but every other tube tester says she's a good one. Let's try the EM test now. I'll try to do this correctly this time. So we change to BEBD8. Am I looking at the right one here? Yeah, BEBD8. BEBD. Get that off there. That should have been on. 8. There's 8. 14. This is where I made my mistake. I tried setting the bias to 14 when I should be setting the bias knob to 14. Like that. Where's the 0? 0 is right on the money. So that's on 14. And I guess when we're doing the EM test, it's a good and bad thing. It's a replacing good, replacing good. So here we go. Well, now that test, it's way up in the middle of the good, really does match the other tests that were done on this tube. Let's see how sensitive this EM shunt adjustment is. So it makes a big difference. And what about the bias? So bias makes a difference too, but not quite as much. Okay. What do we do about that? The GM test bad. So I'm going to stop. I'm going to reread the GM adjustment process and think about what I'm going to do about this. Let's put this back here. Or should I do another tube? Could it be something specific about that tube? I don't think so. I really don't. But I will think about this while I have some coffee. So I remember during the calibration process that when I tried to calibrate the A setting here, I got nowhere. And I just made a note of it. In the meantime, I've looked at the chart of tube settings for tubes, and this A setting is seldom used. So it's not a high priority, but this is involved with the GM measurement, of course, and the GM measurement seems to be off. And this control, even though it's not set on A, it's set on B, is part of this area that's got a problem. So I think what might make sense is for me to consider redoing the calibration process for this setting, and then again, if it doesn't work right, then try to figure out what is wrong with it, and that may lead me to what is wrong generally with the GM test. That's my thinking on this. So no reason to have this on, actually. So I need to sort of reverse all the way back to where this is being adjusted pretty early on in the process, and see where that takes me. Okay, so the position A, right off the bat, in one of the earliest steps, is called plate bridge balance Make certain the switch plate shunt is in position A, 30. Temporarily attach the resistor. Do all these settings. And it says, where does it actually say what you do? Here, rotate test switch to test and note if meter deflects off 0. If it does deflect, try adjusting potentiometer P4. I thought it was P3. P4 located on the power supply chassis for practically no deflection. When I performed this test, there was never any deflection of the meter at all, no matter what I did. So gave me the impression that something is not connected right. P4. Turn power off, remove resistor. So I have to put that resistor in to do this. Here's a GM adjustment. So when I tested the 6C4 for its transconductance, it also came out low compared to the other testers. So it's a consistent problem with two tubes. Something is definitely wrong. Screen balance. Well, you know, I think what I really should do is do this very first step and figure out why it didn't work. Why I couldn't get wherever it said it. Somewhere in here. Anyway, yeah, I think that's the idea. So I'm going to pursue that. This one here. We'll pursue this first thing. Plate bridge balance. Okay, what I'm hoping for is that what I'm about to do doesn't invalidate every other calibration thing that came afterwards, but it could very well. It's got the 2K resistors in place. This is the adjustment here. I'm going to tip this down. 14. Okay, and let me just read the instructions here. Controls A through O, bias and filament, maximum counterclockwise. Filament 2, right? Filament. You're supposed to have a tube in here? I don't think so. I'm going to pull that out. That's right on 0 now. Controls A through 0, bias and filament at maximum counterclockwise. Meter switch to line. Meter switch to line. Short switch to test normal. Meter slide switch to normal. And bias slide switch to 10 volts. Test switch to off. Test, this is where I get confused here. Test switch to off. Insert line cord. Push on off line. Just line adjust to center scale. Switch meter to test. Rotate test. Switch meter switch to test. Rotate test switch to test. And note if meter deflects off 0. P4, not 14. P4 is over here. Okay. Maybe that's a mistake I made. Maybe I was turning the wrong control. Oh, that's a bad mistake. That's a classic error doing alignment or calibration work. Is you're 3/4 of the way through it, and then you turn the wrong control, and it's back to square one. Okay. So let's do this stuff then. Turn it on. Okay, we're going to go on with the dim bulbs first. Just that's going up. Just let it go up. Insert line cord, push on, switch to on, adjust line adjust, panel control to center scale reading on the meter. Switch the meter to test. So we're on line. We want this to be in the center. It's almost there. Put this in the center. There we are. That's straight up the center. Switch meter, switch to test. Switch meter, switch to test. Rotate test switch to test and note if meter deflects. Okay, wait a minute. We gotta change a few things here. Okay, first this gotta go down. This gotta go up. It's operating at too little voltage. This is off. This is back to line. Oh, just happen to turn it to the right spot. Go back to test. Test. So there's a slight difference here on the meter. It's very, very slight. I think we can get a better look at it if I simply just stick the camera right on here. Let's see how this does. Oh, hold on, tangled up cords here. Okay. Let's see what this looks like. Oh, perfect. So we're a little off the zero there, and I don't know if it's the meter mechanically is off zero. I should re-zero it. I have to turn the unit off. Let's do that. Turn the unit off. And the meter's not moving at all. Okay, so I'm going to zero it with the this adjustment here. Adjust away. Okay, that's definitely a mechanical zero on the meter. Good. Turn the unit back on. Oh, I want to keep that. I want to keep that meter there. I keep that camera there, so we can keep an eye on this. Okay, let's go back to doing the test now. That's a little parallax thing happening there. Let's put it and line it right up, bullseye it. Getting a pretty nice reflection from my equipment up there. Let's go. Okay, what's happening is the camera wire keeps pulling the camera down. Hey, the needle's bent. Huh. I wonder why it's bent like that. It's taking a beating or something. It's not quite on zero, is it? Or is it just a little more parallax? It could just be, it's just parallax. Okay, we're ready now. So we're just going to read the instructions. I better not rely on my memory at all here. Line adjust to center scale, switch meter switch to test, rotate test switch to test, and note if meter. Here we go. So we're going to rotate the test. So I'd say a little wee bit. Okay, so I'm going to try this P4, right? Now, you know what? So I'm going to mutter here a little bit. So I'm looking at the rewritten instructions this time. But I know there's an error. I believe, I don't know, I remember there's an error in the instructions. Could it be right here? If it does deflect, try adjusting potentiometer P4. Adjustment of P4. Okay, you're just staring at that. I'm gonna. Okay, I'm ready to adjust P4. No, I'm not. Use a different tool here. Okay, now I'm definitely ready to adjust P4. No, I'm not. My tool fell out there. Okay, here we go. This is definitely P4. Yes, no question, P4. Okay, here we go. Hey, what happened now? This P4 thing is very, very sensitive. So that's me adjusting P4. much precision do you really need here? This is with the test switch on. Pulled the tool out and moved the adjustment slightly. I mean, that's got to be close enough. Good. So that adjustment worked this time. I wonder if I was going after the wrong adjustment by accident, you know, P14 or something, I don't know. Okay, so, but that didn't make much difference. There was hardly any adjustment, so that's not going to explain too much. For crying out loud, this is not in the right position. How did that happen? How did I make that mistake? Okay, let me just read these instructions once again to be absolutely sure what I'm doing, but I am sure. I said right in the front first line, make certain switch S5 is in position A. Ah, how could I have made that mistake? Okay, now it's in position A. We will check the line adjust again. It's way off because we're in the dim bulbs. We're in the dim bulbs. We're actually in the dim Jim's shop. That's really what's going on. So, okay, so there we are once again adjusted. Now we flip the test and the meter's off a little bit. Just a little bit. Okay, P4, make sure I got it. P4. P4 is right beside the 5U4 tube, and I just feel the heat coming off it, and I know if I just touch the glass with my hand, I'll burn myself. I'm a little anxious here. Okay, let's put the camera back on for a good look at this. Okay, so here we are. So we're going test. Barely off. Okay, I'm going to try to adjust 14 here. Oh, for crying out loud. Come on. Ah. Hang on a sec here. I'm going to get this camera to stabilize. Okie dokie. We are. Okay, I think I'm ready now. Here we go. Test. And I'm adjusting. Off, test, test. Off, test, test. Okay. That's got to do it. Again, hardly any adjustment, so no reason to be too panicked about the whole situation now. Something I haven't mentioned for a while, and that's the misbehaving meter here, which sticks at the high end. If you notice, I've been doing all this kind of stuff, and it's never gotten up high enough to stick. And it looks to me like that problem is getting less and less. Okay, so what? So I thought I adjusted this A. Doing the adjustment I just did, the meter did not move. Something was wrong. Well, I may have had this on B. I may have been turning PT14 by accident. Who knows what I was doing. Got it done this time. Now, the question is, did that throw everything off? Hard to believe it threw everything off to any great degree. And what exactly am I adjusting there? What was that? Let me just look again at the chart. Plate bridge balance. Wow, it does sound like it would affect everything. That comes next. I'm looking for a reason why the machine is reporting about half the GM that's actually there. So this is not a satisfactory situation at all. I'm sure if I put that tube back in and test it, you're going to get the same half result. I haven't done anything. Somehow I was hoping that this A thing would lead to a resolution, but it didn't lead anywhere. Okay, I'm going to stop for a bit. So I was just standing here asking myself, why would the GM test fail? Why would it fail to work? Or it appears to be failing to work properly. And I don't know. So time for some more information. So this thing has some interesting facilities to reveal the voltages and signals it's using on the tubes you're testing, and I think that's through this O control in the plate here. So I'm going to experiment with that. What I literally think I can do is, as I snap this around, a voltmeter hooked up to here will show me the voltage, or if I hook my scope up here, I'll see the signal that's being applied to that. I don't think this is a pin number. I think this is we can relate this to the different elements in the tube. I think there's a statement that says all these switches do the same thing. So if one is a plate, it's a plate, 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 plate. Same thing everywhere. Does that make any sense? Okay, it made sense to me. This is still on, and I best to turn it off because I'll make a mistake. Okay, so if that's the case, we want to test a tube in here. I don't want to put the big honker in there. It's we'll set up for this tube. You know what I'm going to do? I'm going to test this in another tube tester first. Get some results on the piece of paper from tube testers I trust, and then we'll test it in here and compare it and go from there. Then we'll fool with this and with that. And fool. You can't fool a fool. He's a fool. Somebody famous said that. Okay, so I measured the GM on my Stark 966 tube tester that I believe is quite reliable, and it came out at 1700 micromoles. So I'm looking in the book now for 6C4, and under there's a couple of different operating conditions here, but transconductance here is listed at with low B plus 3100 and higher B plus 2200. Well, that's funny. That number's written 2200 again. What did I get? 2200? Anyway, it doesn't matter. I'm just confused. So we'd be looking at something like, well, between 2200 and 3100. This is low in comparison. A little low. Maybe you would say 70% of its potential value. Let's take a look at what's the reject point. You know, I forgot to note the reject point. I gotta go run look at that other tube tester again here. Whoops. Okay, let me double check the settings here for 6C4 just to be absolutely sure. EGGG, and that doesn't matter. 40650, 40650, and 12,000. 12000. I had an error in there. How do you like that? The bias setting is 4.8 volts. I've tested this tube. What here it is. 6C4 in my 966. The reject point is just about 1400, and brand new is 2200. This thing's testing 1700, so maybe 60-70% of its, I don't know, maybe that would be a percentage number. Certainly not perfectly good, and certainly not throwaway bad. And the throwaway number, or the bottom number, is 1300. That kind of compares here, pretty close. So we will now put the tube in and measure it and see if it comes anywhere near 1700 like the other tester. Okay, let's put the tube in. This is definitely 6.3. Hit the power. Give it a moment to warm up. Got to warm up the whole thing, the tube tester too. In the meantime, we can check. So to do the line properly, you need the tube conducting, but you don't want to have the tube conducting until you've performed a couple of basic tests, like for instance a short test, which would be a good idea. 1, 2, 1, 3, 4, 5. That's exactly right. Yep. So you know there's no shorts. The bias needs to be set before you fool around too much, so we can go to bias here, roughly set it, because we haven't done the line yet. So bias is 4.8. 4.8 would be just about 4.8 right there. 4.8, right? So we'll check the line voltage now. It's very close. Adjust it up a little bit. Okay, we're back here to check the bias. We've just gone up a bit, so we'll put it back to 4.8. Bingo. Put this on test. We are ready now for the GM test. There it is. Okay, I'm going to put this on hold. And we'll read this number very carefully. So we're on the 3K scale. So on the 3K scale, well, this is really, really low. Low number. Point. This is reading like 300. 350. I'm reading this absolutely right. So we're on the 3K scale. Here it is here. 0.5, yeah. So this is reading 350. That's a far cry from 1300. And go way, way below the reject point. So we throw this tube away according to this tube tester, but no. So the next step in this now is to try to measure voltages using this plate pin technique and this control and see if that actually works. So I'm going to take this off test for now and stop for a minute, and then we'll do that. Let's take a look at this information, which I think is very valuable, and thank you to the viewer who pointed this out. I kind of read through the manual, skipped through this part, and didn't really absorb how important this is. So here you're told what kind of voltages are being developed in the machine as you change this setting, the plate voltage switch. So that's kind of interesting. That's something I can look for. Look what it is actually though. G, which is the setting for doing a transconductance measurement, it just says 160 volts pulsating DC to the plate. Now we looked at that on my scope earlier. It's definitely something there. Primarily used with the transconductance measurement. The rest of them primarily used with the EM measurement, and all these different voltages, 20, 50, but look, they're all AC voltages onto the plate. So I think as long as I have the plate switch, I guess it's D, in the G position, then I should see 160 volts as the plate voltage. Now this is interesting information also. This shows that each one of those 10 pin switches, I don't know what to call them, goes to the same thing. So it doesn't matter which one of the switches you turn. If you set a switch to 3, you've connected the screen supply. Now switch O appears to be connected just to the plate pin jack. So that would mean if you rotate O through these different settings, you are driving this result to that connection. You should be able to see it on a meter. Filament 3. Filament number 3 is connected to filament number 2 through a... This protects filament arrangement where there is a tap radio for a pilot light. Consider it tube. Okay, so it's just, you might... Displace the aroma tapping it. The use of the connecting lines is explained in another section of this book. I got to find out about this connecting line thing too. This is an interesting feature inside here. So let's play around with the switch O and see what happens when we switch it through these different settings and what shows up on a meter. Okay, got my meter here. Turn it on, and then the idea is you're just putting it in here and in the ground here. Okay, the set is on. It's still in the mode of testing the 6C. I've got this set to 600 volts. Well, I got it set to DC. So we'll turn this on. So this is at 0. And I believe rotating the switch does nothing more than make different connections to the plate pin up here. Hope I'm right, because here we go. So this is pin 1. See, the voltage has dropped. Interesting. Pin 0 shows a voltage. Oh, pin 0 shows the test result. Pin 0 is definitely connected to nothing. Wait a minute. Wait a minute. If this is connected to nothing, then this is connected to nothing. How am I getting a plate reading here? Okay, Jim, you don't know what you're doing. Or you're misinterpreting things terribly. Or am I? I'm pretty sure pin 0 is connected to absolutely nothing. Under here, I can't quite see it. Let's look. Let me look. Maybe. So I rotate this to pin 0. That's where it is now, isn't it? Yeah, it's on 0. If I look at the connecting, the contact tab is sticking out in space here. It's not contacting anything. If I go to position 1, it's in contact. Ooh, what was that click? What was that other click there? Well, we're getting, oh, that's vibrating, so that, whoa, watch out, man. I'm gonna do something bad. The fuse light came on here. Oh, this is not a good idea, Jim. Not a good idea. I have the distinct feeling I don't know what I'm doing there. So I think my thinking is wrong. I'm gonna stop and look at this a little closer. Well, after reading the manual a little bit, the connecting line starts becoming an issue. So the unit is turned off right now, so there's no power in it. So connecting line. So if you look, if I set this is selector O. If I set it to its number 8 position, the little connecting tab, the contact is here, connecting to this number 8 line, and look, this wire just goes to the same thing here, and 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 all the way across the bottom too. So that's the connecting line. Now, how would that help you in some way? So if you turn this to the connecting line, then what would, they talk about turning the N1 a lot to achieve current measurements through the pin jacks. That's not what I'm interested in. I'm looking to read plate, grid, screen voltages. So I got a portion of the connecting line story here, but not enough to make any use of it yet. Okay, coffee and read the manual some more. Okay, so I'm going to try to explain the use of these two switches. I'm probably going to get this wrong because I'm having a hard time understanding it. But each one of these, it relates to a particular pin on the tube. So this is pin 1, pin 2, pin 3, 4, 5, 6, 7, 8. Yep. I don't know what goes on with pin 9 and a 9-pin tube, but this and this are very special. So I think the way you do this, let's say, I don't remember what these are. Let's pretend this is the plate. So you say, I want to do something with the plate. So you take this off of 6. This isn't switched on, right? Put it to 8. 8 is the connecting line. Turn this one to 8. This switch is connected to the grid. This switch is connected to the plate. So this one, so I've now connected the the third pin of the tube to the grid. Now you can turn this to select the plate, and I can't remember again. I have to look at the chart. I won't bother. Just pretend. Okay, so now the plate voltage that was intended to go here is going here. What that means is if you run a wire from here to here, you've reconnected the plate from its normal connection. I'm making this up again. From its normal connection down through here. And what this allows you to do then is put an ammeter in here in this particular case and read the current flowing into any one of the elements in the tube. Could you be testing a tube? You know, literally go, how much current in the screen, how much current in the plate. That's what I think I'm heading for. What I thought I'd try to do today was detect the voltage of these different elements through the use of these switches. I'm not so sure I could do that. Because what I've read so far is how to basically insert an ammeter into the element circuit using these switches. So I think I probably got this 80%. Let's see if I can figure out how to drive a voltage up onto one of these two and therefore be able to read the voltage that's being applied to the tube. That's really what I want to try and do. So back to reading the guide some more. Okay, when I look at the schematic, this control appears to only be connected to the plate terminal here, nothing else. So as you select along, as I'm thinking, you're picking off, I can't remember the order, grid, plate, screen, I can't remember. And it was heater, 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 3 different heater settings, and then finally you're at 8 here. I've got my oscilloscope connected. You can see it in the top corner there. So I don't think, I think with this tube tester you should not be turning these controls, certainly while this is in test mode or hold position. But even otherwise, I think there might be a problem. Why don't we find that out right now? Is there going to be a problem? So the way to see this, I'm going to turn it on, I'm going to put it through the dim lights, the dim bulbs, and flip this switch. Kind of watch what happens, especially with the dim bulbs. Here we go. Otherwise, this has been reset. I should reset this. It's all set for the 6C4. Give it a little bit of time to warm up. Is there a bias setting for the 6C4? .6C4 bias setting on the GM test is 4.8 volts. Let's just check that stuff first. So check the line. It's a little low. I just looked over at my scope and saw this big AC signal on it. Bias. It's supposed to be 4.8. It's very, very close. 4.8. Very good. Now, I've left this on 1, and I probably shouldn't have. I should have left this on 0. Oh, it's still showing a hum. How can this be? You would think if you snap this to 0, this is now open. Unless you're in the E mode up here, which we're not. If you're in the E for an EM test, situation's very different here. So this is only, what I'm doing is only really valid for the GM test. Well, I haven't hit the test switch yet. What happens if we do? I'm on 0 here. This dropped a bit, and did you see the dim bulb? Okay, so all it's doing is causing the tube to draw some current. I think everything's normal. So I'm going to advance this to the next position. Then watch everything, dim bulbs too, because I thought I saw, I'm going to go right around and watch the dim bulb there. Nothing happening at all. Okay, so I don't know what I think I saw last time. I don't know. So now the question is, I'm going to turn this guy on too. So I didn't see this change at all when I was turning this. I thought the display should change. Is there something wrong with how I've done this? It's definitely ground. Oh, the ground wasn't making contact. Ha! For crying out loud. Okay, now we're in business. So with this off, I will rotate once around and we'll see what kind of voltages are there and what kind of signals there. And I want to look on my own screen here at the chart that tells you what is what. So just hang on one moment here while I find that chart. Where's that chart? Well, I got so many sections of this guide on my computer here. Got to be down here. Got to be here. Okay, just bear with me a second here. I just want to get a chart in front of me. Here we are. So switch 0 is no connection. No connection. Switch 1 should show grid supply voltage. We see nothing anywhere, but I will now flip this to test and we'll see what shows up. The dim bulbs came on. You know, that's probably what it was. Probably turning the tube on scared me. Now, this is not a calibrated thing by any means. I've got the dim bulbs in the circuit, so we're way low here. Maybe we're too low. Let's take the dim bulbs out because I don't think I need them anymore. Now we'll check the bias and the line and all that stuff. Get it all corrected. Bias right on 4.8. Once you correct the line, the bias should follow because it was set previously. Okay, so we're in test mode to do a GM test. So if I hit test, on this meter we will see the result. Ooh, what happened there? How come it's jumping up and down like that? Put this back to, let's put this on 0. Try it again. Okay, so I'm getting a reading now, comparable to previous readings. Why did I set this to 1 and we don't get that? No, I changed it. I don't understand. I can understand it changing it here. Why on this meter? Okay, again, with this on off, I'll flip this around and we'll just watch everything happen. Nothing is happening anywhere. Ooh, a little bit of a hum on that. So I'm getting to the 3 that connect to the heater. And then off. It's a little hard to see, but there was a bit of a hum showed up here. The scale on this is pretty big. This is 50 volts per division, so you need quite a voltage to move it. Why is this not behaving the way I think it should? If you look at the schematic, it's extremely simple. The output of this switch goes through a it goes through something. Let's take a look here. It goes through something. Down to the schematic. Goes through this. This is the EM-GM switch. It's all connected together. It's one long switch all the way down to here. All this stuff. When you flip that switch, it's only got 2 positions. And we can see, if we look, here's that plate pin jack. I still don't understand this thing right here. I don't know what that means right there. We come down through here, around and into the middle. So right now, the way the switch is shown, the output is connected to back here. If we snap this switch, you can see the arrow there. One setting over will connect to 3 and 4. And then the plate output is connected down this way, which is the EM plate supply, which varies depending upon settings. Why does this not work right? It's definitely on the G. It's on the GM setting. There's no doubt about it. So even though it says plate here, which is kind of misleading, isn't it misleading? Because what out here, it depends upon how you set this switch. I don't know. It's not making a lot of sense to me that this wouldn't work unless there's an error in it somehow. There's an error in it, some kind of wiring error. You know, you can have a wiring error in here and never discover it. If you never use this plate connection, you'd never become aware that there's something wrong. So whoever built this may have never performed the kind of tests or goofed around the way I'm goofing around. They may not have discovered an error in what they've done. That would be up to me now. Oh my gosh. Let's just check this one more time. Rotate the control all the way around. Just watch everything. Yeah, okay. I am a little anxious about doing this because unexpected results. So we're at number 8 here, which means this is connected to the connecting line. Nothing else is dialed up to 8, so nothing is connected also to the connecting line. So this is open. I'm going to go just 7, 6, 5, 4, 3. I want to get that chart up again. Sorry. I got to get this chart up again. Just bear with me here. You don't have much choice, really. Oh, I guess you could fast forward. Okay, here we go. I'm just here we are. Okay, so 0 is no connection. 1 goes to the grid supply. So I would like to snap this all the way to 1. So I'm going to cut the power briefly. Put on 0, power back on. Snap it to 1, and we should see grid on the. Here we go. I watch it. I don't have the dim bulbs in anymore. So how are we going to know if this thing is really sucking back the power? We can look at this meter. Another one too is this guy here, which you can't quite see. This meter here, it ranges from 100 volts to 120 volts. So this is quite sensitive to any fluctuations. So if this thing starts drawing a lot of power, this meter will drop a little bit. Okay, here we go. Number 1. Okay, nothing bad happened. Got nothing here, nothing there. This is supposed to be the grid. We have to put it into test mode to see it. That's probably the case. This test switch hasn't got millions of wires coming to it. Let's try it. Here we go. Test. Okay, so yeah, this didn't behave properly. This didn't show anything up. Scope didn't show anything at all. 2. Okay, nothing bad happened. Nothing here, nothing there, nothing anywhere. We got the test result this time. It's not behaving at all the way I think it's supposed to behave. I don't like that. Number 3. And test. Okay, so the meter's misbehaving again. So whatever I'm doing here is doing a lot more than just affecting this terminal. How can that be? Why would that be? A wiring error. It's kind of what it comes down to. Test again. Oh, I didn't like that one. See, the pilot light went right out. I don't know if you could see that or not, but it went right down to nothing. So this is a bad thing I'm doing. I'm going to stop doing the bad thing. Okay, I'm going to stop for a minute. I may stop for today, actually. I'm going to stop for now, though. Okay, wire tracing here. Now this will be hard for you to see. It's hard for me to see in here also. But if we start at the last switch, the switch we're interested in, that's this one here, and we can see that when it is set to that's the contact that's moving here, 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 picking off all these different wires. If you look at these wires carefully, you'll see that there's a set going across like this, a set going across like this on all those switches, and then jumper wires jumping the two sets together. So they're actually all the same. Sorry, it's very, very simple. Hard to make a mistake there. So we follow this. This contact is always in contact with the wheel. So you're selecting these and sending it to this. Where's this go? this connects to a black wire, which is this wire here. Yeah, no doubt, this wire here. It's coming up to the top of the switch. This switch is this switch, the short switch. So the voltage that, or whatever signal you're picking up from switch O, delivered here. This is in the test normal mode right now, and this terminal is connected to this terminal. This one is open. So this is the I was going to say that this is the yeah, that's right. Whatever you select here will be presented as a voltage here. It's going to come through. It's going to reach this guy, come through this coil and resistor combination, a filter of some sort, and come through here. This is the I can't think of the term, suppressor. So coming through here, getting onto this black wire. Where's this black wire go? You trace this black wire, there's no question, it goes to the plate terminal. The terminal called the plate. Pin jack, I guess is the right word for it. I can't see that there's anything wrong. I can't see there's any reason why this wouldn't work at all. I just love these cognitive crises that these things generate in me all the time. It must work, but it doesn't work. I'm being gaslit by a tube tester here. So how to prove any of this? I suppose I should turn the machine on, get the tube tested, take out my voltmeter, and just check all these and see what shows up. Like the same basic thing I'm trying to do with the pin jack. Just do it right on the actual thing. What do I hope to see there? I hope to see that there's stuff there, and then when you're switching this, the stuff should be delivered out to the plate pin jack, whatever the stuff is. Maybe it's just a dirty switch in the end. I don't know. Okay, so that's what we'll try. Make the have the device operating, doing a tube test. Put the test switch in hold so the test is on completely, on continuously, and then check voltmeter or scope would be better. Check around here. What do we got? And I could compare that to other spots. They should all be the same because I can see the wires. They're all there. Nothing looks wrong. Nothing looks shorted. Okay, that's what I'll try next. Okay, so I've hooked up my scope to what I believe to be the plate supply line that's running through all these switches. Switch setting shouldn't really matter. I should have the plate voltage as long as I'm in GM mode anyway. Would probably carry the plate voltage if I'm in EM mode also, but okay, let's turn this on. I don't even have it connected. Let's turn it off. We don't need that. We're going to look at the scope here and kind of watch what happens. Okay. So I'm expecting 160 volts with a big wave in it. Okay, here we go. I'm switching on through dim bulbs first. Okay, then we're going to go full Monty here. We're not in test mode yet. We're just... All I gotta do is just flip the test button to test. Okay, there we go. Test button to hold. There we are. Let's snap it on and off. Well, is that quite what I expected there? So on the voltage side of it, it's 50, 100, 150. So the peak is right in the area, but I thought this was supposed to be a, like that just looks like a half wave. Actually, it looks like a full wave rectified voltage. I've got the scope on DC. put on AC will do that. Put it back on DC. And the 0 line is here. So maybe you could say, yeah, it's a pulsating DC. I guess you could say that's pulsating DC. It doesn't look the same as the last time I did this. The voltage is right and it's pulsating. Now, how come we can't find it on the output of this switch? And with this, what did I see there? Oh, just a shadow. So we'll go on the output of the switch now. I'll try anyway. There we go. I get the same thing. Excellent. So as I turn the switch, we should see different things. It shouldn't affect the tube test at all. We should just see different things. So this is plate. Let me get on the list here so we know what we're looking at. So we're on number 4, I think, right now. Yes, 4. 4 is the plate. 3 is the screen. So okay, so I'm going to turn this to 3. That's the screen. 2 is the cathode supply. Well, there's nothing there, I wouldn't think. And then 1 is the grid. And probably it's just because I've got this thing so insensitive. Ooh, that's a sloppy thing on the grid there, but that's kind of a weird thing, isn't it? So all the stuff is there when I rotate the switch. Now, why is it not showing up? So I believe it shows up here. Yeah, I'm going to switch it back to the, grab the right switch. Grab the right switch. Switch it back. That's screen. That's plate. We'll leave it on plate. So it's making it to the switch here. It should be making it out of the switch right here. Yeah. It should be on the other side here. Yeah. Now it's following this wire to this terminal. It's there. Well, why wasn't it there before? Okay, so if we put the scope on the pin, I'll try to do it here. On the pin jack. If I can get it. Don't get a shock here. I can't get it to stick on. Should really do it on the front, but danger, man. That's 160 volts you got there with a pulsating thing. I'm sure that would make me sing pretty loud if I got that on me. Okay, here we go. There it is. Now the whole idea is rotate this switch and just see all the different voltages that the device is delivering. So we go back, screen, cathode, grid. 0. Oh, wait a minute. It's not 0. Yeah, it's on 0 setting. You can't quite lower. We're still got a little bit of stuff here. What would that? Okay, don't know why it's on there, but here we go. Back again. Grid, cathode, screen, plate. Now we go to heater. Okay, heater. Just making sure nothing. Watching this meter down here to make sure that we're not doing something terrible. We did nothing terrible. This is the connecting line now, which is basically open, and you can see that it does pick up a little bit of probably nonsense. So what's the story? This is working fine. It's working exactly the way I expected it to work. Why did I not experience this earlier? Cool. Now, okay. So it's supposed to be 160 volts when read with a meter. I believe read with an RMS meter. Let's check it out. See what we get here. So we're reading from here. Hey, don't spin there. To, we could read it right here. Oh, for crying out loud! Slap me in the head. I left this on amps. Oh my gosh. Anybody see that? People scream. Were you screaming? Yeah. That explains everything. Yeah, you never know where the problem is, but usually it's somewhere, has something to do with me. That's usually the state of affairs. Okay, now we're cooking with gas once again. Oh jeez, whole morning to find that out. So we're expecting 160 on the meter. Getting half of it. And we do get a low GM result. Half of it. Well, really, you start thinking a rectifier circuit or something like that. Nobody moving around here. Okay. Well, that's good. I know I'm kind of stumbling around, but that's how it goes. I'm going to stop at this point, and tomorrow we'll carry on and try to resolve the problem of the low GM reading. And it looks like it's probably related to the low plate supply. You know, that could be a resistor's gone high in here somewhere, if I can find one. Yeah, that could be what it is. Who knows? Thanks a lot for watching. I hope you're getting a kick out of this. I feel like I'm making some progress. I'm certainly getting very familiar with the device, which is the part of the benefit of doing this. Great. Great. Okay. See you tomorrow.